Well, good morning. Okay, class. Today we're going to have a lesson on gravity, weight, mass, density, relative density, and buoyancy. So yes, we're covering a lot of ground today. You better pay close attention, get your notebooks and pencils, and we'll get started here. First, our joke of the week. My mom's dog died, so I bought her an identical dog. She said, so for our lesson, back to our lesson, here are some definitions. Mass. Mass is an intrinsic property of matter. It has basic units of kilograms. Whether you're on the moon, another planet, whether you're floating in space, or simply at different elevations on the Earth, mass does not change. Okay, let me repeat that. Mass does not change. It's often confused with weight due to the units of kilograms. Next, weight. Weight is a force. Okay, weight is a force. Mass times acceleration, and the force is due to gravity. So for all of you that think weight is not a force, it is, and it's due to gravity. Weight has units of pounds or newtons. If you're in the SI units, it also has units of kilograms, which is what causes the confusion with mass. Its value will change based on gravity. So if you go to the moon, your weight is 1/6 of what you weigh here. Okay, density. Density is an intrinsic property, and it's calculated by mass divided by volume. So density is related to mass and volume. It can be thought of as the amount of mass per unit volume. Its units are kilograms per meter cubed, or for smaller amounts, it's grams per cubic centimeter. An example, the density of gold is 19.3 grams per cubic centimeter. If you want to view a comprehensive table of intrinsic properties for gold, you can go to this URL here, environmentalchemistry.com. They have a whole list of what an intrinsic property is. So things like color, malleability, and so forth. All of these things are intrinsic properties, so is density. Okay, next, relative density. Be sure you understand this one. Relative density is a comparison of an object's density to that of a standard density. Okay, so usually it's compared to water at the same temperature. It's calculated by density of the object divided by density of the standard, and it has no units. You're dividing the units of the object divided by the units of the standard, it has no units. You can change it to a percentage by multiplying by 100. So the relative density of gold compared to water at the same temperature is 19.3. It's used as a reference. So along with relative density, let me explain that relative density disequilibrium is not a term used anywhere in science. If you hear this term, it's just a made-up term. It doesn't mean anything. Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object. So in a column of fluid, imagine, a pipe or something. In a column of fluid, pressure increases with depth as a result of the weight of the overlying fluid. Now remember, weight is related to gravity. So weight pulls the object down and buoyancy pushes the object upward. These are opposing forces in a fluid. There is something called the Archimedes principle, which has to do with objects that are partially submerged in a fluid. Okay, partially submerged would be like a boat or something like that. A helium balloon in air, these are examples of buoyancy. A helium balloon in air, an egg in salt water, a butterfly in air. These are all examples of buoyancy. So mass versus weight. If they're different, how can we measure them? Weight is measured using a scale, such as a bathroom scale. The scale uses a calibrated spring, which provides an upward force against the force of gravity. So you have this spring that when you step on the scale or when you put something on the scale, it goes against the force of gravity. Mass is measured by a balance, such as the one shown here on the left. The object to be measured is compared to a set of calibrated standards. So again, here we have these little cylinders that are standard weights, or standard masses. And you put the masses in the one side, put your object to be weighed on the other side, and you can get a weight. There are other kinds of balances that are used for many different things. When I worked in laboratory, they used a balance that was all enclosed in glass because it was so precise that they didn't want it affected by air, the air movements or whatever, people moving. So it was okay. So here's our first test question. Everybody get your caps on, and here we have an apparatus that appears to be measuring some apples. So is this apparatus measuring mass or weight? Mass or weight? I'll give you just a second to look at it. You notice those gray looking standards over to the right. That might give you a little clue here. So yes, it's mass. I hope you all got that. let's talk about a force before we get into these next couple of things. A force is a push or a pull on an object resulting from the object's interaction with another object. Whenever there's an interaction between two objects, there's a force. When the interaction ceases, the two objects no longer experience a force. Forces only exist as a result of an interaction. This next thing is very important. You need to be sure and keep a note of this one. A force is a vector and it must have a magnitude and a direction. Always. It always has a magnitude and a direction. Now, here are Newton's laws of motion. You may have heard these and not known exactly what they are. Newton's first law of motion is the law of inertia. Second law of motion expresses the relationship between force, mass, and acceleration. The third law of motion states that for every action, there's an equal and opposite reaction. That's probably the quote we hear most. So Newton's first law of motion, or the law of inertia, states that every object is in a state of uniform motion, tends to remain in that state of motion unless an external force is applied to it. This means that there's a natural tendency for a moving object to keep moving unless an external force interferes. We can talk about helicopters that go straight up. They're going to keep moving in the direction that they were moving before they went straight up. So if they're sitting on the earth, they're moving with the rotation of the earth. According to the second law of motion, acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force required. Force equals mass times acceleration. So F equals ma. This is another quote we hear a lot. Force equals mass times acceleration. For gravity, acceleration is 9.81 meters per second squared. Okay. The third law of motion states that for every force, there is a reaction force that is equal in size but opposite in direction. Therefore, whenever one object pushes another object, it gets pushed back in the opposite direction equally as hard. You see this a lot in the movement of an airplane. The engines of the airplane push to the back of the airplane, and the airplane responds by pushing in the opposite direction toward the front. Rockets do the same thing. There is a burning, a fire at the bottom of the rocket, which pushes at the back, and then there is a reaction to that by the pushing of the actual rocket toward the front, so the rocket goes forward. Units. Boy, I've heard a lot about units lately. Units are not just math and not of any use in the real world. That is not a true statement. You use the units anytime you do any kind of calculation, and it's important to keep the units going along with your calculation, because you could get confused and end up doing the wrong thing. Here's a very simple example you guys do every day. If I travel 200 miles and use 10 gallons of gasoline, can I calculate my gas mileage? Sure, everybody knows. So let's take 200 miles times 10 gallons. That's equal to 2,000. Well, that can't be right. So look at my units. Miles times gallons is not equal to miles per gallon. So we did it wrong. Let's try 200 miles divided by 10 gallons, which equals to 20 miles divided by gallons, or 20 miles per gallon. That's the correct calculation. Obviously, we can see if we did it wrong, the units are wrong. If we did it correctly, the units are correct. So here are some of the units. I mentioned them in the definition, but I wanted you to have them in a table. Force is kilograms times mass divided by second squared. Notice that the mass per second squared, that's acceleration. Kilograms is mass. Okay, so it's kilograms times meters. I think I said mass. Kilograms times meters per second squared. Mass is kilograms. Weight, you can use kilograms. It's also newtons or pounds. You can convert newtons into kilograms and vice versa, but that's what weight is. Density. Density, remember, is mass per volume. So density is kilograms per meter cubed. Volume is a three-dimensional. So kilograms per meter cubed. Relative density, remember we said relative density has no units. Units are all canceled, and so there's nothing. Buoyancy. Buoyancy is a force, so it has the same units as force. Kilograms times meter per second squared. Kilograms times meter per second squared. Okay, here's a new test question. Over here to the right, you can see Mr. Riley with his egg experiment. The top picture is plain tap water, and the egg is at the bottom. The middle picture is salt water. He had prepared salt water. The egg is in the middle. At the bottom, he dumps a lot more salt. You can see there, he dumps salt into the glass, and the egg floats to the top. This yellow wording over here, you can see the yellow wording is counts of dissolved solids. He has a dissolved solids meter, and that's what he was using that for. So our test question, what causes the egg to move and why? So think about what you have here. So you have an egg, he adds salt to the water, and the egg floats. So you've had some time to think about that. I got these pictures and so forth from Dr. Bob, and it's this link that's at the bottom. So if you'd like to, if you want to go look at that. I also noticed that that Simon Dan posted a video this morning talking about, or one of the things he talked about was this egg experiment. So did you figure out what causes the egg to move and why? What causes the egg to move is the force of buoyancy. Remember that Newton's second law says we can't have any motion, unless there's a force. There has to be a force. So it's the force of buoyancy. Why does it move? Because of the change in density of the fluid. Mr. Riley will freely admit that it's a change in density. That is correct. However, he will not say it's because of buoyancy. So here's another question for thought. This is not a test question. I just want you to take this with you and try to think of what causes it. You can answer in the comments if you like. I always watch the comments, so you can do that. The question is, how can the force of gravity hold down 320 cubic miles of ocean and yet allow a butterfly to fly? How can the force of gravity hold down 321 cubic miles of ocean and yet allow a butterfly to fly? What forces are involved that allow a butterfly to fly? You can think of that. That'll help you with the answer. If you can't come up with it, leave me a comment and I'll mention it in my next video. So, joke of the week. My mom's dog died, so I bought her an identical dog. She said, "What am I going to do with 2 dead dogs?"